Hi everyone, this is Miss Caspero. I am talking today, this is 14.3, Measures of Variability, which means how far they vary from the mean. So in this one, we are looking at the interquartile range, the semi-interquartile range. Hi, okay, I'm back. I had to step away and put the information into the calculator. Didn't want to waste time on a recording doing that. Once you've got it in, stat, edit, remember, and then you're going to put it into L1. And once you've got it into L1, you will hit stat, calc. One variable stats will give you everything you need. That is your mean, 26,093.37. The sum of them all, and then you've got this, your standard deviation, which we'll deal with later. Now, here are the 5 points you need: your minimum, your Q1, your median, Q3, and your maximum. You have 47,476. So, what we've got here is, okay, a minimum, Q1, your median, I was going to put Q2, which is the same thing, but we'll write median, Q3, and then max. Okay, that was the 47,476. I remember that one. Okay. 1790 and 20,925. And the last one is Q3, which is 28,285. All right, so our interquartile range is going to be the Q3 minus Q1. We got that listed wrong. Missed my minimum. It's 2095. Missed my median. Got to scoot these down. 17,090. And then the 20,925. Okay. So 22,836. That's what I'm missing. All right, that was my median. But you definitely have messed up my interquartile range. That's 28,285 minus 20,925. So that, 8 minus 2, 6, 12 minus 9, and then that's 7330. So that interquartile range means that the middle 50%, middle 15% of colleges are within that 7360 range. Okay. The semi-interquartile range is simply 7360 divided by 2. Okay? Now, that, okay, 7360 divided by 2. It's 3680. Okay? So, if you were looking, when we had it on the last page, we were looking for outliers. It is the interquartile range times 1.5 above Q3. So let's see if there are any outliers. 7360 times 1.5 is 1140. Okay, so that would be 28.285 plus 11,040, and that will tell you if you've got something above that, that's an outlier. Okay, plus 28,285. That's 39,325. So actually, our max there is an outlier, because that was 39,000. What was it? 325? 325. Yes. All right. So that was what. That is an outlier, as it turns out. Okay. Now the 20,925 minus 11,040 leaves us with 19 minus 11, 8,885. That's below the minimum. We're okay. That's the minimum is fine. It's not an outlier. But that 47,000 is an outlier. In fact, we've got two outliers. They are both above that 39,000. So that's where that is coming into play. All right, box and whisker plots are used to summarize data, and we use these right here in box and whisker plots. Okay. Usually cut off you will put in your other max before the outliers when you're graphing. Okay, so we had it right here, the Q1, Q2, Q3. The least value was 17,090, so there was our minimum. Q1 was 20,925. Q2, which is our median, and Q3 is 28,000. Now remember, we had the outlier, anything above 39,325. 39,325. That was going to be our max value that we could have. Okay. After that are outliers, and we had an outlier at 45 and at 47. So when you are graphing this, you'll have an outlier here at 45 and then another one here at 47. Your box is going to be around the middle three. And draw it up to the max. And these two will be your outliers. Okay, so we had the minimum Q1, median Q3, the maximum value before you hit your outliers. This is actually maximum value, but it is an outlier. The highest it could be is 39,325. Okay, this is another measure of variability. It's your mean deviation. And what it is finding out how far away from the mean you are. So, what it's doing, just so I can kind of break it down for you, we had a couple listed here. I'm going to use these. The 17,090 and the 2925. 17,090 and the 2925. What these things are looking for, these are just two values, and I was showing you what it's doing before I show you how to do it on the calculator. It is taking the mean, and whichever one is higher. So if I had the other one up here that was 28,285, that's higher than the mean. I would do it the other way. That's why we have the absolute value here. But when we are doing it, we're going to say 26,093.37 minus 17,090. And you're going to get a value. Then you've got the 26,937, 993 and 37 minus 20,925, and you'll get another value. This one's higher, so this time I'm going to do 28,285 minus 26,093 and 37, and you get another value. Now these are just 3 of the values. If these were all of the values, then it would be pretty easy. You've got your mean, okay, and you subtracted them off. So 26,093.37 minus 17,090 and gives me a value of 9,003.37. 9,003.37. All right, my second one. I have 26,93.37 minus 2925, 5168.37. And then the last one I had was 28,285 minus 26,093.37, 2191.63. Whoops, 91.63. So, what we started out with was you added up the original data, okay, added up original, got a total, divided by the number you had, and got a mean. Then we subtracted this from here, okay, and we got all the differences in there. You're then going to add all those up. And once you add all these up, you'll divide by the number you have, and you'll get another mean. This is your true mean for your data. But this right here is the mean deviation, because this is how far everything has deviated from the true mean. Now, there is a way to do it on the calculator, and we have done that before. So don't forget these. The first thing you had was stat edit, and you enter the values into the L1 column, which we did. And you have stat calc. Click 1, which is one variable stats. L1, because this is where you're getting your data. Click enter. And then write down your mean to use later, which in this case was 26,093 and 37. Highlight your L2 name and click Second Catalog. Choose your absolute value of, and you write your column, L1 minus the mean. Click enter, and your list will appear. So that's what we had to do here. You hit Stat Edit, go to L2 and click Second Catalog, absolute value of L1 minus that 26,093.37. When you click enter, your column appears. When you